Alright, in this video we're going to be starting the process for generating new chunks. This will probably be another multi-part series, but this should be, at most, I would assume 3. So the first place we're going to start is within the event graph. I've made some changes, that being the removal of the spawn chunk function. So not the complete deletion, we've moved it elsewhere. So if we open up propagate collapse, we'll see upon the completion of our while loop, so that means the propagation has been completed, that the spawn chunk is now over here. However, we have some new variables. So what is generated chunks? This is going to be a map in which we save all relevant information to chunks that have been completely collapsed or generated. So this is a new variable, like I just said, generated chunks. It is a vector of a new struct. What is that struct? I've named it collapse chunk info. Opened up, we see here 3 variables of tile map, that integer, and our tiles, rendered tiles. This is a paper tile map component in the case for 2D. If you're working on a 3D, you would just do whatever type of like array you have for all spawned actors or whatever you're doing, whether that be instanced meshes, or so forth. And then a simple variable boolean just for whether or not it is currently loaded. And you could save more complex information here. If you want chunks that differ in size, as an example, you would probably want to save their specific chunk size, whether that just be X, Y, or Z. So for now, we'll just do these 3. And as I said, generated chunks will now be pin vector with a value of that new structure. And we just need to add at chunk position. The first chunk will just be 0, 0. And as long as we are correctly updating chunk positions based off of where we're trying to collapse within the greater world, this will always work. Then we just need collapse tiles. The rendered tiles does not need to be changed, and loaded neither, because we have just done the calculations for the collapse tiles and we haven't actually spawned it in, which will be done right here with spawn chunk. So we need to go, once all of the rendering has been completed, on completed of that loop, we need to run a set members and collect chunk info. That's done by just running a find, pulling off, getting set members. And you'll have something that looks like this if you've never used set members. This is pretty useful, as it allows us to not completely erase or override information as we would if we just did a simple add. If we were to just do an add without doing a set members, we'd have to make sure we split this and then add in each variable correspondingly to not lose any information. However, when we do a set members, we can then come up here, select what we want to change, and then it will let us update those and still maintain whatever whatever we don't select. If there was any information, any variables, whatever, will still be maintained in there. So our tile map will go unaffected. It will still contain all collapsed tiles. And then we just need to set that paper tile map variable as the rendered tiles, say it's loaded, pull from struct out, and then add it at chunk position. So this will have all of the necessary information for the future now. Okay. From there, just trying to think. Oh, that's right. We need to, in propagate collapse, clear the collapse tiles map, as we need to collapse more chunks. So we don't want to pull old information into a new environment. As well as with the entropy array, we're going to run a quick check on it. We're going to check if they are not empty. The indexes, the arrays within each index of the entropy array, if any of them are empty, we're going to clear it. You could also use this as a safety stop, because we should be exiting any propagate collapse with the entropy array being completely clear. So if any of these aren't clear, that could be room for errors and issues. As it stands right now, this algorithm with my tile set especially is very simple, so it's not prone to errors. So you could set up something here to maybe rerun some checks. That also, we don't need to then also clear this, because the while loop is inherently decided by whether or not our tile options is empty. So this is just going to be a safety mechanism for now. I usually haven't used it. This algorithm does work quite well, so the expectation is that this should be empty, but that's always not always the best coding mentality. So, oh, I have a cat that wants to step on my keyboard. All right, come here. Perfect. That should be it for this video. In the next video, we're going to go over a little bit more complicated. It's a lot more math and reasoning. Okay. Behind how we're going to get information from one chunk to the other to have a proper continuous collapse. So I'll see you in that video.